remind everybody that in order to field questions, what we're going to do is ask that you submit those through the chat. I'll be checking those periodically, and we're going to get to those near the end of the presentation. So what I'll do, Gary, is I'm going to unmute you, pass you the presenter ball, and I'm going to take myself off camera so that I'm not distracting, mute myself, and enjoy the presentation, everyone.
Great. Can you see my screen just to get a confirmation of that?
We can. I can see your screen. It looks good.
Excellent. Okay. Well, once again, as Lauren said, we are very happy to be here. Very happy that you took some time out of your day to sit in on this. There are a lot of new capabilities in SciFinder-n. I'll try to touch on as many of them as I can in an hour session, but I think you'll be quite impressed with some of the things some of the new capabilities that do exist here. So as a kind of start, I'm going to go in and actually I want to look up some work of a specific author, and there is the ability to do an advanced search here under references. So if I click on that, let's say I know where this person resides. So I can pull those back, and that brings me back all the publications by that University of Michigan. I can now go down to the author section, and here's a big new capability. We've always had the ability to search with your authors from most cited to least cited, but with the new SciFinder-n platform, we have a new search engine, a new data model, and that allows us to search without limits. So that means you'll be getting some, in cases, very big answer sets back. We saw here there were over 250,000 publications associated with this search, which means there'll be a lot of authors. And so when we're doing some of these filters over here, we give you not only the ability to filter by top count, but also by alphanumeric. So if I know what the last name starts with, I could refine down by that. And what I do 95% of the time is I actually just go into the search. As I said, I knew something about the author coming into this. So I can now search last name, first name, and that brings back all the possible authors that are in this data set that could satisfy what you might see for a John Wolfe. You know, could be have names abbreviated. There might be a middle initial. In this case, luckily, I know that the middle initial is P. So if I want to make sure I've brought back every possible way that you could get a answer set back for this author, I've done so just in doing that. Glad I got someone's advisor, some publicity here. All right, and so here are all the answers that come back. I can scroll through these, and the reason I'm doing this is I want to kind of show an additional capability, and you'll see down here there is this thing called citation map. So what is that exactly? So that's a capability that we put in that allows you to do a couple of things. First of all, it'll bring back all the citations of this work. And these are all over here. And we not only bring those back, but we also are able to tell you how many times those articles have been cited. So if I'm reading an article in a given area, might be nice to know not only what articles are in there, but how many times have those been cited. So if I'm looking for, you know, kind of seminal publications, looking high on this list in all likelihood is giving me some other articles to pursue if I want more information on this topic. The unique and differentiator here is not only do we have those references in there, but we actually tell you how many times this article has been cited. So all these articles over here are articles that were published where this piece of work was cited. And once again, not only that, we tell you how many times those were cited. So this is a 2019 publication. It's already been cited 29 times. So that's telling you, once again, that other authors are out there, they're citing this work. Probably good reason to maybe go in and take a closer look at that, especially if I'm interested in this topic area. As I scan down really quickly, we help you out in quantitation here. As you can see, as there get to be less and less sightings, it gets lighter and lighter. So just if you're scanning through a large list, that can kind of tell you that you go down certain orders of magnitude in citations. So this is another great way, if you've published some articles out there, to see if other people are citing your work. But like I said, it's a good way on a given topic to walk it forward. And so this was published in 2018. What other articles out there that have been published since then have cited this work? So I can kind of, like I said, follow that type of thing forward. In the end, I was interested in this article, and a new capability that we have here is if I click on this title, I have the ability actually to set up an alert. So like I said, I thought this was a great article, and I might like to know anytime this work gets cited again. So by clicking on the title, coming into this, clicking on the alert button there, I can now set up an alert. And I can run that whenever I want. And we also have the capabilities for it to be run automatically. For those of you who've been on SciFinder web for a while, you've seen the weekly and monthly before. We recently had a lot of customers saying, you know what, that's great, but I'm in the cutting edge here, and I would really like to know as soon as any citation that satisfies this query is out there, can I get a notification? That's what as available is. The day that we upload a publication that satisfies one of your alerts, you will get an email alerting you to that fact. So once again, just our attempts, hopefully, to work at the speed of science and technology here and keep you abreast of all of the new publications that are relevant to your field of work. So, just to point out, I've already got 3 tabs open here just to further expound on what Lauren said earlier, that I can operate in multiple tabs if I need to. Once again, if I think about something and want to do a sidebar, I can do that in another tab and come back right to where I was left off. So now let's expand our look at reference searching. One benefit of me being remote is that you don't have to watch me type. I can just cut and paste things in. So I want to look up a certain topic. And in this situation, I'm looking up calcium channel modulators for the treatment of epilepsy. And something that's nice here that is new for SciFinder-n users is the auto-suggest. As I'm typing in this query, it will actually suggest from the company thesaurus, the database thesaurus, other ways that I could end that query that I'm putting in there. So the topic that I want, and then associated with things like drugs or seizures or reflex, so on and so forth. This also is a great avenue to help you finish off the spelling of difficult words and things like that. So it'll suggest, do you want to end the word this way? And then you don't have to struggle through the word schizophrenia or something like that. Anyway, so here's the topic I want to search, and I'm going to go ahead and I'm going to launch that search. What's new about the SciFinder-n versus the SciFinder web is that your results will be brought back not newest to oldest, but by most relevant. And why do we do that? I've told you earlier on that you can search without limits. And even here, 45,000 size answer set was probably something you would have bumped your head against the ceiling of the ability to, of the size that you could pull back previously. But here, no problem with that. I've had answer sets come back that go over 1 million, and you're saying, well, Gary, that's great. What am I going to do with 1 million answers? Well, and that's the key thing to having a relevancy algorithm. Even though I've got 45,000 answers, in all likelihood, this relevancy algorithm will help me find extremely relevant articles even on the first page of my search results. So, and how does it do that? So it's taking your search query up here, and it's looking for the words in the title, in the abstract, and in the concepts. Just to remind you, as Lauren pointed out earlier, we have all human curators here. Every article that you see, every patent that you see has been read by a degreed scientist in the field. After they get done reading that, they will associate concepts with it. And concepts are basically, what were the key topics in this paper? What were the things most relevant to this paper? You can see this is got a larger paper with quite a few different topics associated with that. And you can see how our search terms, the search terms I put in, have hit on a number of these different concepts. So if you add up the scoring associated with that, and for the times it was in the abstract, and for the words that we found in the title, they'll add it all up, give the article a score, and then it's going to put the articles into your answer set, highest scoring, second highest scoring, so on and so forth. So no matter what size my answer set is, in all likelihood, on this first page, I'm going to be seeing very relevant articles to exactly what I'm looking for. Something else that we wanted to highlight here, that when I do a search, I'm searching both CA Plus and Medline. We've now deduplicated those answers, so this article will appear in both databases, and rather than you getting 2 citations in your answer set, you only get the 1. And not only that, but we associate, Medline does a similar thing where they associate what the key topics are for a given paper. So now you get the benefit of basically 2 different sets of eyes looking at this article and associating those concepts. And this is a huge deal because some of these concepts may not appear in the abstract. So if you were searching for something and you didn't have these concepts associated with it and it doesn't appear here, you may not find that in your literature search when you do that. But having human curators, that's the benefit of it, and that's the benefit of us deduplicating and then retaining the concepts from both databases. So then why don't you hit on the Boolean capabilities of the search field up here. We have the ability to put in Boolean operators like and, or, and not up here to help you refine down your search topic here a little more. And let me kind of walk through that practice here. So right off the bat, we always encourage common language, and that's fine. But once again, I've got 45,000 hits here, and maybe I want to tighten that up a little bit and come back with maybe just things that are most relevant to me. The first thing I would say here is I said calcium channel modulators. Right off the bat, I'm seeing or blockers. So maybe I want to incorporate that term into my search term here. But the first thing I'm going to do is show a way to kind of eliminate some of the noise. So for the treatment of, there may be certain search terms where the term treatment is key, but treatment can be applied across every scientific, every probably pharmaceutical, agrochemical field, and you might get a lot of answers that maybe aren't precisely suited to exactly what you're looking for. So what I'm going to do here is I'm going to associate this first phrase here with the last phrase by linking it with an and. So right away, if by doing that, I take this down considerably. But remember, I said I had that term blockers in there. So I'm going to or blockers into this query, and so make sure, depending who it is, they may refer to it a different way. And so you can see I brought back some additional answers, but still a fair number here. So what I'm going to do now is I'm going to put this in parentheses, and I'm going to put in the Boolean operator and again. So calcium channel and modulation or blocking and epilepsy. And then the last thing I want to do before I'm satisfied with this query is, see, it brought it down considerably. I'm interested in modulation. So it could be modulate, it could be modulator, it could be modulation, it could be modulating. And we've introduced the ability to put in wildcards here. So now any of those words I just talked about will be pulled back. If you're at all concerned about completely covering the topic area, that's the way to do it. So and I'll stop there with the refining, but you can kind of see the different. I just want to highlight the different ways I could actually do that. And so I've got something close to 4,000. As I look through these, I'm pretty happy. I've got my blocker in there. I see here's one where they didn't say modulation. They only use blockers, so it's a good thing I add that in, or I might not. I could have pulled it back because there are a lot of other my terms in there, but it might have been a lot lower on the list. Anyway, so I've showed you first of all the relevancy algorithm. I've showed you the ability to play with your search query in the search box and what we can do there, and then we have all these filters over here on the left-hand side. So without me doing a single thing, I know that my answer set has 966 patents in it. Some of these are filters we could have done before, but you had to do some additional work to introduce them. The new search engine and data model allow all this stuff to happen instantaneously with the search. So some of the other capabilities here by role. If I want to look at just biological studies associated with this search query, I can find out by that. Something that's really nice is the publication year. If I blow this up, you can see as I fly over each year, it will tell me how many of the answers in my answer set are from that year. If I want to look at just the things in the last 10 years, I can do that. Or I may have said, you know what, when I was in grad school, the article came out. I can't remember, but maybe if I refine this down, it will come back to me. I can take it down to 116 just by knowing something about the exact period of time in which an article appeared. We walked through the author bit already. Organization. So this is a great way to find not only maybe potential collaborators on a given topic, but it's a competitive intelligence tool as well. If you're working in this field, who else is working in this field? Kind of like to know. Maybe I should learn a little something about neurosearch or look up Xenon Pharmaceuticals, what have you, and see what else they've got out there and published. Maybe I can look at. Maybe I know somebody there. So very valuable thing. And just as I said previously, I have all the additional search capabilities in that field as well. Concepts. So I showed you where those concepts were, and they're a very nice thing to use to refine things down further. So I still have several thousand answers in this, and I might want to actually refine this down a bit. So I'm going to actually I want to look at just those concerning voltage-gated calcium channels. So, and you can do quite a few things here. Not a field of my expertise. So what I'm going to do on this one is I'm just going to go ahead and select all those different concepts to associate with my search here. Moving on. It's quite a long list. Already talked about, Lauren pointed out what this refers to. This is another product that we provide, and for those that are trying to find ways to put the molecules in, give them the appropriate characteristics, solubility, stability, what have you, being able to deliver to the locus of action in the body. Very, very important function in the lifetime of the development of a drug. So we have provided a database that will help in that purpose. There are also filters within SciFinder-n itself. If I'm looking for formulations for a specific purpose, I've already talked about, maybe I'm interested in calcium channel blockers. So if I want to see the formulations, work on formulations around that topic, I can click on this and I'll bring back just those articles that have that information in it. And the last thing I want to get to here is you have the ability to do a search within results. This is just a text query in the abstract concepts and title. And in this case, I just want to refine things down a little bit more about what I'm looking at. I know it. I want N type to be part of my query as well. So in the end, I've taken, I think I started with 45,000 some answers, and I've gotten down to 461. In the end, I'm happy with this query. As a matter of fact, I might even like to save this or share this with a colleague. So what I can do, and I have 3 different options here. First of all, I can download this search. If I want to download it, I have a number of different options here. I could do an Excel. Is very popular because you can have the information in columns and you can sort, search, things like that. So that's a very popular way to do it. And I haven't refined down mine far enough, but if I want to have a detailed result downloaded, which it could include, if I want to, concepts, substances, other information, I could do that. Or like I said, I could switch and say, I want the Excel back, a possibility there. So that's one way. And once again, these are things, if I had it in the PDF format, I could download it. I could email it to collaborators and coworkers, that type of thing. The second thing I can do is if I want to share this exact query, I can put in the email addresses of the people I want to send this to, and then send this off a little message so I can tell them, they can know what they're receiving. And then once they, that will send them a hyperlink. Once they click on that hyperlink, they're brought to right here. Now it's in essence their search. They can play with it. They can say, oh, okay, yeah, this is great. You know what? I'm more interested in what we got in the patent area here. And what may happen is your colleague or coworker may play with it, find a little something out on their own, and they may email a link back to you saying, hey, thanks for sending me that link. Hey, I played a little further, and look who the big player in this is in this area. We should contact these guys. I know someone in this lab. We could probably set up a collaboration or what have you. So just to say that this could be a nice collaborative research tool as you can kind of, everyone can look at with a different set of eyes and refine and make new discoveries. So that's the second way I can save this. The third way is the way maybe we're more familiar with is I could save the search. And in this vein, I could give it a name. I can associate tags with it. And with those tags, I could even now color code the tags if I want to. So I may have a number of tags in here. The maroon tag is the calcium channel blocker project. My blue tab is another project that we're working on. Just different ways that rather than you spending a lot of time trying to figure something out, ways to color code and file and collate allows you to get to what you need as quickly as possible. Something I want to additionally show you new capabilities in this vein is I have abilities to now manipulate my saved queries. First of all, if I have queries or keep me posted from the SciFinder web version, I can click one button and they'll all migrate over and they'll be called alerts in SciFinder-n. The second thing is I have the ability to combine search queries. So let's say I want to take some of my reference search queries here, and I could add two of them together, two separate searches I ran. Maybe I just want to sum them all up and give that a different title, and I can actually then associate alert with that. If I've run two queries and I want to see what were the common elements between the two of them. So you recognize this is the or, the and then this is the not function of Boolean operation. Maybe I ran a search 3 months ago. Maybe I ran it again today. What are the new things? And so I can use the subtract function if I want to. So if I did that, once again, it'll give me an option, what's data set 1, what's data set 2, and then it'll perform the operation. And then once you're done, like I said, you have the ability now to set alert on that if you so desire. Then the last thing I want to show here before I move on is the ability to do a combined search. So I've done this, I put the search together, and I would like to see not only the results I get back from that, but there's a specific molecule that I'm interested in. And I want to see who else has been working on a substructure of this molecule. So what I'm going to do here is I'm going to actually bring in a structure to my query. Use the draw tool here. And up here, look at this box. I can bring in structures by putting in a CS registry number, a smile string, or an itchy string. In this case, I've got a CS registry number. And this translates text into structure. And there is the structure that I'm bringing in. And for my specific situation here, what I'm interested in doing is I want to see how many people have used this portion of the molecule as a substructure in molecules they've synthesized. I'd like to see all the different analogs that are out there because I'm interested in this. What have people produced? What have they found? Is there data associated with these? So I've got this substructure query, and I'm going to go ahead and upload that. So it's going to run this reference search, and then with all the substances associated with that, it's going to look for this substructure within them, and then bring me back an answer set saying all the articles that satisfy or have a substance in them. And so out of all those articles, 4 came back. And so what happens here now is I can click on the title, and then when I get into the abstract, I can go down to substances, and you can see what happened here is it brought, even though there's 506 substances in here, it brought to the top of the list all those substances that satisfy the substructure that I was looking for. So, here's one that had a thiophene with and without a salt. Here it had the additional ring structure that we saw before. Lots of things with thiophene, furan, so on and so forth. So this gives me a quick way to pull back the like 19 structures in this one that were analogs that would be potentially of interest to me. And as I said, there were 3 other articles in there, so I could look at all those. So that's just ways that I can quickly access all that information. And so that is what I have to show you in the area of reference searching. So I'm going to go over to reaction searching. I always have this problem. I always get a little bit behind because I start waxing poetic, and I need to probably pick up my pace here a little bit. So let me do that. And I'm going to switch over. I'm going to get rid of what I have up here already. And I'm going to switch over to reaction searching. And I'm actually going to go into my history to pull up a reaction that I've previously done, so you don't have to actually watch me draw it out and things like that. So just hopefully you'll realize that it helps this kind of pick up the face. Actually, it's right here, and edit drawing. So most of the audience is probably experienced in the use of the CS draw tool, but here's a query that I'm interested in, a transformation I'm interested in. And aryl aldehyde boronic acids plus alkynes to give me these chiral indenols. So let me walk through some of the capabilities here. You have the ability to create up to 20 R groups in the CS draw tool. As I fly over an R group, it's going to tell me what the components of are of this. What have I put in this R group? So I can choose from 3 different areas. I can pull elements out of the periodic table, nitrogen, oxygen, sulfur, so on and so forth. I can use some of these shortcuts that were created for you. If I don't want to draw out a phosphate group, it will do it for me, and I can plop that into the different functionality in my R group. And then lastly, we've created certain variables, any halogen, any metal, carbocycles, heterocycles, so on and so forth. And then the second feature I decided to highlight here is use of the variable attachment tool. If I plop down my R group here, I can now click on this. I can click on this, then click on the R group and the point on the ring in which I want to see, if these different function groups have appeared there. So I have one R group for here, one R group for here, and you can see where they end up in the product. So anyway, that is the reaction I want to search. I'm going to upload that to the search bar, and I'm going to execute that search. So it bins them for me in a couple of different bins. First of all, as drawn is what I have here. For those of you that are used to the SciFinder web, it was brought back by document. You still have that ability here, but we've introduced this additional one by scheme. And what that is we found 3 different examples of this exact transformational literature. That's my as drawn bin. So this satisfies exactly the query I was looking for. What I drew and the R groups I put on there. This falls within those guidelines. So it comes back in the as drawn bin. And so it takes those 3 exact transformations, it plops them into one scheme. So I can look at side by side the conditions here. One use cobalt, one use rhodium, one use palladium, sorts them from highest yielding to lowest yielding. Additionally, it will, if there are experimental protocols associated with this article, I can click on that and pull those up. For those of you that may have not seen our methods now synthesis product before, In the SciFinder-n platform, you have unlimited use. You may have seen it previously, but you only can use it like 5 times a year. Unlimited use now that you guys have upgraded to SciFinder-n. So the human curators break out this reaction to this nice tabular format, products, reactants, catalysts, all in their own line, all hyperlinked. I want to investigate these further, look into suppliers, maybe do a purchase, I can do that. And the procedures have been broken out into this nice recipe style format. Times, temperatures, amounts, workup conditions, all put into this. Takes a lot of guesswork out of the procedures you find in the literature sometimes. Lastly, if there has been characterization data associated with this procedure, we will provide that for you. So a really great way for you to be able to find this, walk right into the lab, you know what you need, how much you need of it, and then once you're done, shows you how to isolate it and then characterize it. So you can see, yeah, it was successful, or maybe something went wrong here. So that's the methods now synthesis capability. Addition, there are a bunch of filters over here on the side. So let's say, you know what, I need to be operating in 1,4-dioxane. Click on this, it'll just bring back those reactions with 1,4-dioxane, or I have a specific catalyst in mind, that type of thing. So if I just want to see the ones that have methods syntheses associated with them, I can just look at those. And we've been talking about the as-drawn capabilities. The benefit of doing it by document would be if I'm looking up transformations where maybe someone's done like a combinatorial research on it, or really explored the characteristics around the transformation and has done 200 examples. If I group it by document, then I don't have to go through all the individual transformations. I can just get to the appropriate article that's talking about what I want, and then look at just those transformations associated with that article. And then one last thing on reactions before I move on. I want to go into substructure, and the new capability we have there is non-participating functional groups, and why might that be of interest? So I'm interested in this transformation. Obviously, that's why I searched it. But I'm thinking of an application in my research where I have a specific functional group in there that I'm a little worried about. I'm seeing metals, I'm seeing heating. I'm like, is this going to survive or not? So what I can do is I can click on View All, and these are all the different functional groups that appear both in the star material and in the product in this answer set. In my specific situation, I've got an aldehyde. So this will bring me back the one example in this answer set of that. And as it brings it back, it shows me the reaction. Here it is in the star material, here it is in the product, and I'm relieved to see that this goes in 93% yield. Not only that, I have an experimental protocol associated with this. So that allows me, once again, to have something when I go into the lab to help me get things running, and some spectroscopy to use in assessing my success. So once again, just the ability to have this rather than you going into the lab. Like if we didn't have this capability, we would bring back lots of different conditions for you, but you'd probably have to say, well, these 5 or 6 look the best. I got to go in the lab. I got to try 5 or 6 reactions. Maybe that takes me, the better part of the day. Whereas using the filters over here, I've come to these exact set of conditions for my exact situation. And maybe I just need to go in and try this one set of conditions. So rather than me spending the whole day putting together a whole series of reactions, I can do this and maybe probably do something else as well. So just giving you information you need to only do what is absolutely necessary, and provide you time for other things that are needed as well. All right, so now I'm going to move on to substances. And this is one situation where I wanted to show a little bit of something. I'm sure I've got a vast majority of chemists out there, but a lot of people say, chemical abstracts or CAS. There's a lot, we provide information across disciplines, across scientific disciplines. And one thing I like to point out is, let's say I had interest in a specific enzyme, alkaline phosphatase. So I can go in and search that. In the end, I'm going to want to, maybe look for a sequence or something associated with that. So when I do this initial search, it's going to bring back the generic alkaline phosphatase. There won't be any sequences associated with this. When you're looking up enzymes, you do need to provide some type of species information. So just to show you, for example, if I say human alkaline phosphatase, that's going to bring back the generic, and then the ones that are more specific. So you can see here it says sequence length 308. So if I click on the CS registry number there, and then I get in here, I want to see the sequence details there. It brings up the sequence details for me. I can see exactly what they are. Also provides some other information about what bioactivities has this been associated with this, other targets that it interacts with. So just something to keep in mind for both chemical and biological structures. There is a lot of information behind that CS registry number when you do the initial search. And just in the off chance I do have some biologists out there, to let you know, on the horizon here will be coming the ability in SciFinder-n to do biosequencing, so like blast searches, those type of things. So keep that in mind. But yeah, and then just the last thing I want to say before I move on, if I really had no idea about the species, what it does provide for you is the ability with, once again, using like a wildcard, it'll pull back absolutely everything. So there's 413 substances we've associated alkaline phosphatase, and here you can see all the different species that are out there. And as I'm reading through these, maybe it's something spurs like, yeah, it was E. coli, a certain E. coli strain. So then I can go and refine my search a little bit, and then refine down just to those things that I'm most interested in. All right, so getting back into chemistry, there is a compound that I'm interested in. I want to look it up. And here's my compound. Once again, just to point it out, let's click on the CS registry number and look at all the information that's behind there, some of the key physical properties, other names, compound, and this is a therapeutic that's on the market for B-cell cancers. Over the course of its development, it may have had many names. It may have been an asset at company A that got sold off to company B. Company B got acquired by company C. So publications from its prior life are out there, and when you run across them in the literature and say, that looks like olaparib, all you need to do is take the CS registry number, click on it, you have all this other names and identifier information for you. If I'm looking, if I want to find some experimental spectra associated with this, I can click here. It's got a proton and a mass spec associated, hyperlinked if I want to go in and actually take a look at it. We also provide predictive properties and experimental properties if they're out there, but there aren't any for this one. And we use ACD Lab software to do this function here. So you can see log D, solubility information, density, Lipinski properties, polar surface area. These are the different things we calculate for you. And if there weren't experimental spectra out there, we calculate a proton in C13 using the same ACD Lab software. I showed you the bioactivity indicators with the alkaline phosphatase. There's also a lot of different bioactivities olaparib has been associated with, as you can see by looking at this list, and then also target indicators. So something that usually catches people's eye is the cytochrome P450. If you're looking at a specific compound, you might have some interest into does it affect any of the cytochrome P450s. That's a flag for toxicity that will probably jump up and bite you in the behind at some point if you're not aware of it. So once again, all these different things, if I click on this, I would be pulled up articles about the Bex proteins that had olaparib in the paper. So that's the information that resides behind that. If I'm more interested in the structure here, I can click on this and get this flyout window. If I want to look at different analogs associated with this, I can do that here. For example, let's say I'm looking at this. Maybe we have a crystal structure that's out there, and we do some docking, and for a specific application that we want to do, it'd be nice to put a nitrogen right there. So since I'm in the SciFinder-n, what I can do is I can quickly do substance search and say, well, is that compound known out there? Not as drawn, not as a substructure. Okay, not known. Is this covered by any patents out there? So we have a patent Marcouche database, and we can search this structure to see if it is a part of or a substructure of any patent Marcouche structures in our database. So I can click on this and do that search, and it's not. So that's interesting. Once again, so we know that if we want to go down this road and look at potentially making this molecule, there's not a lot out there on it. So there's some white space, freedom to operate, that type of thing. Taking a step back, again, let me click on this, and if I upload the structure, just want to show you if I'm just interested in the structure itself and maybe potential other analogs of it, I can upload this to the search bar and get them binned by as drawn, substructure, and similarity. In your as drawn, it will be the molecule itself. Any isotope containing molecules. Here's one with a C13 here. Here's one that's deuterated. Here's it got a F19 isotope on it. You get the picture here. Then substructures, if there's any point that I haven't explicitly drawn all the valence out, there may be substituents there. I can find this will be the summation of this and the structures I was talking about. And then similarity. If I'm looking for compounds with similar characteristics, it's a Tanimoto similarity algorithm that will find other molecules out there that are very closely related to, but not exactly the same molecule. Then just want to talk a little bit about how we can get structures into the CS draw tool. There are a number of things we can do. I showed you how I can put a CS registry number in and get it there. Additionally, if I was in ChemDraw, I could draw a molecule. All right, taking a while to load. And if you have 18.2 or more recent version of ChemDraw, I can highlight it, and then you'll see these icons light up over here by clicking on the CS draw SciFinder-n. I will, even if I don't have SciFinder open, it will open this window, and then I'm ready to go into a substance reaction reference or supplier search right away. So that's quick. If you don't have 18.0 or better, still your ability to be in ChemDraw or any other drawing tool that has the ability to convert these into smile strings or inchy strings. In this case, I'll pick a smile string. Sorry about that. And I can now paste that smile string here and get my structure in that way. Additionally, I can also upload a CXF or a mol file. So there I had a mol file array, that I had saved, and then bing, once again, saving you time of not having to redraw molecules, things like that. So down to my last 8 minutes here, and I do want to get into the retrosynthesis tool. So let me, in this case, there's a molecule that I saw being worked on at the University of Michigan Medical Center. And here's the molecule. Thought it was kind of interesting, had some nice chirality associated with it. And it's giving me a chance to highlight some of the capabilities in our retrosynthesis tool. So in this situation, what I can do is 2 ways I can launch retrosynthesis. You saw that I clicked on the structure, got this flyout window, and in this flyout window is create a retrosynthesis plan. So when I click on that, it's going into our indexed repository of transformations. and it's using our algorithm finding a number of different ways to make the compound, and then using a scoring function, bring you this specific scheme to the top of the list. And not only that, all the other potential ways we have to make that, we put in backed up each of these steps with alternative steps. So in this specific situation, since these lines are purple, this is telling us this is an experimental retrosynthesis, so known compound, been synthesized before. We went into the literature, we looked at all the different possible transformations associated with the synthesis of this molecule and created this scheme as the best way to approach it. So we're taking this molecule and converting functional groups and disconnecting bonds till we get back to reasonably priced, commercially available starting materials. And what is reasonably priced? That's $1,000 per mole or less. And for each of these transformations, we pull out the literature. We look to see if there was a yield associated with it. If there was, we associate that yield. If there's not one associated, we put it in 50% as a placeholder. Couple that with the fact that we have a ChemCats database. Companies pay to be part of our database, and when they do so, they agree to provide certain information. One of them is cost information. So any place you see this hyperlink, I can click on that, and that will fly you into our ChemCats database, and it will show all the different vendors here and the information like purity and cost. Many of them have a hyperlink to their own supplier website and availability. So I won't go through the whole process here, but I've got 111 possibilities. I can use some of the filters over here. Very common ones where I like it to ship quickly, I like it to maintain in stock, and I'd like it to have a US address so I don't have to worry about delays and things going through customs. So if you associate the cost with the yields, we can give you an estimated yield and overall price to synthesize this compound. Additional information provided with that is we will show you the evidence that we did find. I can click on that and it will pull up those three pieces of evidence and show you them. The first thing I like to highlight here, I haven't gone through, is patent pack. So we provide high resolution PDFs for the patents associated with our database, and for certain subset of them, oftentimes parents in a patent family, we do have a couple of different additional functions, and that's to create a viewer and a PDF plus. So if I click on that, this gives me a high resolution patent, and the human curators have taken all the molecules out of this patent, taken their structure associated with the CS registry number, and written down the pages where it's found. So if this is the molecule that I was looking for, rather than me page through this 152-page patent, all I need to do is click on my page numbers here, and it's going to fly me to the exact points where it is in the patent. Here is the synthesis of this molecule. So I've gotten probably very relevant information. It's probably why I'm looking up this article. But it's associated in a couple of different places. Here's an alternative preparation. And oftentimes you get back to claims, or here it is used in a synthesis of a further molecule. I came in additionally looking for this compound, but as I paged through here, I was like, I didn't know this is part of this patent. I can click on that and do a flyout window. Now I can go and I can look at the reference associated with that, or reactions, suppliers, that whole type of thing. I can do that through another tab, and then when I'm done with it, I can close that tab out, and I'm brought back right exactly to where I was. So people love this functionality. One thing that they did say, though, was like, yeah, this is great. I can use this while I'm sitting on my computer, but is there any way I can get that information in some type of format that's downloadable? And that's what we did when we created the PDF Plus. So all that information is taken, it's put in a table at the end of the patent, and all I need to do is then scan down to the bottom, find my compound of interest, see what page number is on and the identifier, because there's more than one compound on that page. Then all I need to do is go up to that specific page and find my specific molecule. Like I said, once again, it's highlighted so you know exactly which one is yours. All right, so, and let me get out of this. And then very new, in the last month, we brought in the stereo selective capability here. So very important in many situations is to produce the right enantiomer, the right diastereomer, the right stereoisomer, period. And when there is that type of information associated with a given piece of evidence or what have you, we note it by that icon that you saw. And then when you get into your alternative steps, you'll see stereoselective. So I know if I click on this evidence, I can look into that and then look into the article, and I see, here we go. It's got absolute stereochemistry of the chiral centers and the double bond geometry. So if I want to look up that paper, I can do so. And once again, here's one where they've actually got a methanol synthesis associated with that. So just good to know that if you want to actually engage in something like that, which pieces of evidence will be the key ones for you to look at. All right. So, and then I know I've only got 1 minute left here. So let me just very quickly, earlier on, I'd showed you olaparib, and I showed you an analog associated with that. So we searched that, and then I opened this up. I got into the edit menu, and I said, hey, nice nitrogen here, and I went and I found that it's not known and it's not covered by patent. So by the retrosynthesis tool can also give you ways to find schemes for unknown compounds. So here's another way for me to launch a retrosynthesis plan. And initially it's going to come back and show, hey, there's not an experimental retrosynthesis, and I knew that was going to be the case. So what I can do is go into my history here, since I've done this previously. Just give me like 30 seconds here. I will go back to the date that I ran it and pull it up. So rather than all purple lines now, you're going to see some green dotted lines, and that is a situation where that exact synthesis of that molecule isn't known. But looking through our repository of transformations, we can see which transformation is being done there and give you a suggestion. So if I get into this and I look at the evidence, I can see if it's got anything that I think is going to be reasonable. So I'm trying to connect a benzyl halide with an aryl halide. And in my case, there's a nitrogen here, but I'm feeling pretty good about this. 92% yield is almost, well, it is the exact short of that nitrogen and a very closely related benzyl halide. So these conditions I think will work for me. So even though it hasn't been done before, in this manner, I can come up with some fairly plausible schemes that we can use going forward to attack this molecule. So sorry, I went a little bit over there. There's a lot to touch on in 16 minutes or a little less. So if there are any questions that are out there, happy to entertain those. And thank you for allowing me to go a little bit over there.
Yeah, thanks, Gary. Hey, this is Lauren. I think I've been trying to field the questions as they came in to the chat. But if there are any additional questions, we'll give you guys just a minute or so to think about those and formulate those. Gary, I might steal the presenter ball from you for a second, just because I want to share this. Yep, I'll take it back and I'll share my screen. What I wanted to show people is if you have needs for customized training, so we know that there are a lot of different nuances and fields of within chemistry that we may not have gotten to explore here, or some of the features that are going to be most beneficial to you. So like you're doing metal organic frameworks, or if you're doing a lot of stereochemistry, or if you're doing something outside of the traditional areas of chemistry, we'd be happy to talk to you and your research group about customized training modules that we could provide for you and set those up. We also have a series of webinars that are now on our website. So if you would like to attend additional web trainings, so these are going to be typically focused sessions either on looking at patents or exploring substructures, best practices for setting alerts, that kind of thing. Check out our training modules on our website. You can navigate directly using the URL I provided on my slide here. Or if you want to explore our website, cas.org, go to the SciFinder-n page and explore through that there's some resources available to you. So I wanted to make you guys aware of that. Let's see if we have any questions that came in through the chat while we were waiting. like I said, I'm gonna provide this this recorded session to all the registrants. We also have 2 other sessions coming up, one in October and another in November, that are going to have very similar content here, and any additional updates that we have in SciFinder-n between that time. I think if you look at our help menu on the SciFinder-n page, you'll be able to see what's new. Gary, I don't know, did you show them that part? I can quickly show
I did. Sorry.
Okay. Yeah, let me quickly show you guys how to get to that. So I'll go back to my, if you're navigating through SciFinder-n's search page, anytime you're on a page, just scroll all the way to the bottom. You'll go to this help menu. Several of the questions that came in, I actually navigated to the help menu to get exact vernacular phrasing to address those questions. So there was a wildcard truncation question. There was some ChemDraw import questions. You just go to our help page. If you have any questions at all, patents, on the topic of patents here, you can find what we've indexed here according to what your search query might be. I'd also encourage you to check out our help menu under the About SciFinder-n, and you'll see what's new here. And so about every 2 weeks or so, we do a new capabilities upload to SciFinder-n. So you're going to start to see just constant, continuous implementation of features. And so this is something that if you see something new and you're like, well, what is this? Explore the what's new under our help menu to get a little bit more detail as to that feature or facet.
Yeah, Lauren, since you're there, you want to show them where the links to the webinars are under About SciFinder-n?
Yep. So I'm going to go to our web page. This is just going to be under our products tab here. So if you just click on SciFinder-n, the webinar schedule pops up immediately. I think there are also recorded webinars that are available on our website. So if you do want to look at what's been done previously, yeah, you can go towards some of the recent recordings. Some of these sessions are 30 minutes long, some of them are an hour long, but you would basically just go through and register similarly to how you registered for this webinar. So if there are specific topics on here that you find of interest or want to forward to other people, this is where you would go to get those links. I appreciate everybody's time today. Thanks so much for putting this together, Gary. Thanks everybody for taking the time out to attend this. I'll be following up with some additional collaterals. I encourage you to keep in touch with me if you have questions or if you have feedback. I'd love to hear from you. And if you have specialized, customized training needs, please don't hesitate to reach out to me at my email at leiter@cas.org. Thanks everybody for your time. Best of luck in your research. Stay safe, and hope to see you soon. Take care.
Yep. Bye-bye.